To make it easy to understand, I have divided the preparation methods in three categories. The first category covers both aldehydes and ketones, means you can apply these methods to produce either aldehyde or ketone. The first one is by oxidation of alcohols, second one is by dehydrogenation of alcohols, and the third one is from hydrocarbons. Within hydrocarbons, I have two categories here: by ozonolysis of alkenes and by hydration of alkynes. Then I will be covering the methods which are used to produce aldehydes only. Here I will be talking about from hydrocarbons. So there is only this particular method from hydrocarbons, but this has further categories: by oxidation of methyl benzene. Within that, I will be talking about two methods using chromyl chloride, which is ATAR reaction, very important reaction, and the second one using chromic oxide, CrO3. Next, from hydrocarbons, by side chain chlorination followed by hydrolysis. And the third one, last one under this category, by Gattermann-Koch reaction. After that, I will be talking about the category in which only ketones are produced. Here I will be talking about three methods: from acyl chlorides, from nitriles, and from benzene or substituted benzene. This third one is very important reaction, named reaction, which is known as Friedel-Crafts acylation. Now the first category, this one, both aldehydes and ketones. Here we have subcategorization by oxidation of alcohols, by dehydrogenation of alcohols, and from hydrocarbons. Within hydrocarbons, if you remember, we talked about two subcategories: by ozonolysis of alkenes and by hydration of alkynes. First one, by oxidation of alcohols. CrO3 in anhydrous medium is used as the oxidizing agent for isolation of aldehydes if it is primary alcohol. So we have primary alcohol, then we use CrO3 and we get aldehyde. So you need to remember, 1 degree alcohol, you will use CrO3 and you will get aldehyde. If we have to use secondary alcohol, then we will get ketone. So we will use secondary alcohol, we will use CrO3 and we will get ketone. So 2 degree alcohols will give you ketone. Next one under this category, by dehydrogenation of alcohols. Here we have the production of aldehyde and ketone depending on, again, whether we have 1 degree alcohol or 2 degree alcohol. The conditions are same. We use copper at 573 Kelvin in both cases. 1 degree alcohols give you aldehyde, second degree alcohols will give you ketone. The conditions here are that the alcohols here must be in vapor phase. And effectively, if you are using 573 Kelvin, they will be in vapor phase. Tertiary alcohols do not undergo oxidation reaction. So if we talk about tertiary alcohol, it will give you alkene. It is 3 degree carbon, so that's why it is tertiary alcohol. And if we use the same conditions, copper at 573 Kelvin, we get alkene. Next one under this category, that we can produce both aldehydes and ketones. The third one from hydrocarbons, and here we have two subcategorization. The first one is by ozonolysis of alkenes, the second one by hydration of alkynes. So from alkenes and from alkynes, we can get aldehydes and ketones both. In the first one, by ozonolysis of alkenes, this is something we first produce ozonoid by reacting the alkenes with ozone, and then that ozonoid on hydrolysis with zinc gives us either aldehyde or ketone, or a mixture of aldehyde and ketone, or can be mixture of aldehydes, mixture of ketones. Ozonolysis of alkenes followed by reaction with zinc, dust and water gives aldehydes, ketones, or a mixture of both depending on the substitution pattern of the alkenes. I will tell you the way you can identify whether aldehyde will be produced or ketone will be produced. This is one example. Here we have propene. You simply get it reacted with ozone in the first step and you form ozonoid. So to form the ozonoid, what you will do, you will remove the double bond and will form the ozonoid. It is as simple as that. This double bond was there. You removed that double bond and produced the ozonoid. After that, when you get this ozonoid reacted with zinc dust and water, there will be cleavage. And cleavage will be like this. You need to remember the pattern. Cleavage will be like this. So what will happen? This part will give you one aldehyde or ketone, and this part will give you another aldehyde and ketone. So if you see here, in left hand side, you have CH3CHO. CH3CHO. So CH3CHO is produced. On the right hand side, you have CH2O. CH2O is actually HCHO. CH2O, if you take one H here, it is HCHO. And in both cases, you got aldehyde. After next example, I will explain how you can identify whether it will be aldehyde or ketone. For ketone, it will be similar. Here again, we have alkene. This is the main chain, and CH3 is side chain here. You produce the ozonoid in a similar way. You remove the double bond. So double bond was here, you removed it and placed the ozonoid here. Then you will apply same approach, cleavage here and cleavage here. Now if you see here, in this case, it is CH3CO, CH3. I am repeating it. We start from here, CH3, then there is CO, and then CH3. So it will be CH3CO, CH3, which is ketone. CH3CO, CH3. Ketone, propan-2-one is a ketone. On the right hand side, it is similar to what we did in previous example, CH2O, which is actually HCHO. So how to identify whether ketone will be produced or aldehyde will be produced? The answer is very simple. If you rewrite this one as CH3, C double bond CH2, and you have CH3 here, this CH3 on this carbon, I have written as branch here. So the rule is, if there is branch on doubly bonded carbon atoms, then it will be ketone. I am just going back to explain it further. In previous case, on the carbons which are connected to double bond, do not have any branch. So there is no branch here, CH3 like here or CH3 like here. No branch. So if there is no branch, aldehydes will be produced. If there is one branch, this part will be aldehyde. If there are branches on both the carbons, both ketones will be produced. So no branch, aldehyde. Branch, ketone. So that's why in this example, if you see, we have branch on the left carbon. So that's why it was a ketone. No branch on right carbon, it was aldehyde. To get the final product, you even don't need to draw this ozonoid. You can directly get the answer if you are required to get. What you will do in this product, you remove the double bond and place the double bond here with O. I am repeating, remove the double bond wherever it is, remove the double bond and have the double bond O on both the carbons. So this is CH3CO, CH3, and this is HCHO. HCHO is aldehyde. Next one, by hydration of alkynes. In this case, we use H2SO4 and HgSO4. These are written on arrow as Hg2 plus and H plus also. So same thing, if you get it written as Hg2 plus and H plus, or you can get it written as like Hg2 plus H2SO4, or you can get it written as whatever is given, HgSO4, H2SO4. So HgSO4 can be written as Hg2 plus, and H2SO4 sometimes can be written as H plus. So any combination of these four can be written on the arrow. Now, what is specific about it? The specificity of this reaction is that only ethyne will give you aldehyde, all other alkynes will give you ketones. So if it is ethyne, just two carbons, ethyne, only in this case you will get aldehyde. So here you are getting ethanol, which is aldehyde. So what happens here? Basically, in this particular case, you have HOH, H2O. So this is addition of water. This is hydration, addition of water, this one. So what happens? Hydrogen gets attached on one carbon and OH gets attached on another carbon. And obviously, one bond breaks from here. So the triple bond gets converted to double bond. After that, isomerization takes place. Means this hydrogen moves from here to here. And obviously, double bond will move from here to here. This type of isomerism is called tautomerism. Tautomerism is in which hydrogen moves from one atom to another one. So that's how you get ethanol. Now this is CHO group, it is ethanol. And remember, hydration of alkynes, only ethyne will give you aldehyde. All other alkynes will give you ketones. So if you have propyne, as I told you, that now again it will be H will go on one carbon and OH will go on another carbon of the triple bond. And you can remember it as Markov-Nikov addition. Although this is not termed as Markov-Nikov addition, you can remember it like that. OH is negative part. It goes to that carbon which has fewer number of hydrogens. Hydrogen goes to other carbon. So this hydrogen when combines with this one, it is CH2, and OH combines with C, it is COH. After that, tautomerism happens. The hydrogen moves from here to here, and double bond moves to oxygen, CO double bond. And now you get propanone, and this is ketone. And this will happen with all other alkynes except ethyne. In conversions, you will use single step, whether it is ethyne, propyne, etc. So in previous case also, if it is ethyne, you will use single step if it is conversion. Next is preparation of aldehydes only. And in this case, there is one main category from hydrocarbons, and it has three subcategories: by oxidation of methylbenzene, by side chain chlorination followed by hydrolysis, and the third one by Gattermann-Koch reaction. So first one, by oxidation of methylbenzene, we have methylbenzene here. We get it reacted with chromyl chloride. Chromyl chloride is CrO2Cl2. CrO2Cl2 is chromyl chloride in CS2. CS2 here is acting as solvent. Then there is some chromium complex produced. You don't need to know the name of this complex. You just need to write this is chromium complex. You just need to remember the structure here. This on acidic hydrolysis gives you aldehyde. And this is very important, named reaction, Etard reaction. Etard reaction from toluene to benzaldehyde. So by oxidation of methylbenzene, we get benzaldehyde. The oxidation of methylbenzene can also be done by another method, which is using chromic oxide, CrO3. So here again, the reactant and product are same. no difference. But the reagents are different. Now we are using chromic oxide with acidic anhydride. This is acid anhydride. At very low temperature, again we get chromium complex, which on acidic hydrolysis and heating gives you benzaldehyde. Then the second one, by side chain chlorination followed by hydrolysis, and this is commercial method. The side chain chlorination followed by hydrolysis means there are two steps. This is commercial method. In this case, what happens? We first do side chain chlorination. Side chain chlorination means this part will undergo chlorination and we get benzyl chloride. So we get benzyl chloride. Just point, you should note that you have CHCl2. You don't have CH2Cl. Normally in monochlorination, if we are talking about aliphatic compounds, in monochlorination with chlorine and UV light, normally you get just single chlorine there. So if you have CH3, CH2, CH3, then on monochlorination, you will get CH3, CH2, CH2, Cl, or you will get CH3, CH, Cl, CH3. One chlorine at a time. But in this case, on chlorination, that's why we have not written monochlorination. We say side chain chlorination followed by hydrolysis. So Cl2H new conditions are same, but we have two chlorines here and both chlorines are on same carbon, means it is a type of geminal dihalide, geminal dichloride here. And then at 100 degrees Celsius, that is boiling water, it is converted to benzaldehyde. So reactant and products are same, the conditions are different, and it is commercial method. In last three cases, if we talk about using chromyl chloride, toluene to benzaldehyde, then using chromic oxide, toluene to benzaldehyde, then by side chain chlorination followed by hydrolysis, toluene to benzaldehyde. Conditions are different in these three cases. Then third one, by which we can produce aldehydes only. This one we can produce benzaldehyde from benzene. So this one is different, slightly different. Here we are not using toluene, we are using benzene, and we get it reacted with carbon monoxide and HCl in presence of anhydrous AlCl3 or CuCl. Conditions you should remember. It is important to memorize the conditions. And in this case, you will get benzene converted to benzaldehyde. Very important named reaction, Gattermann-Koch reaction. In Gattermann-Koch reaction, try to memorize, it is to convert benzene to benzaldehyde. The last category for preparing ketones only. Here we have three subheadings: from acyl chlorides, from nitriles, and from benzene or substituted benzene. First one, from acyl chlorides. In this case, we have acyl chloride. This group is acyl group. This is acyl group and chloride. We get it reacted with alkyl cadmium. So this is dialkyl cadmium, or you can say alkyl cadmium as well. When it is reacted with acyl chloride, we get ketone. But this alkyl cadmium is produced at the time of the reaction. It is not very stable. So alkyl cadmium is produced at the time of reaction. That's why this first reaction is there, which is extra. We use Grignard reagent with cadmium dichloride to produce alkyl cadmium. So R2CD is produced during the reaction, just before the reaction, and it is used in the second step to produce ketone. So this is first method from acyl chlorides in which we can produce ketones, only ketones. Next one, from nitriles. Nitriles means CN. In this case, we have CN here, nitrile group. We get it reacted with Grignard reagent in presence of ether. Otherwise, Grignard reagent will react with the moisture of the air. and will produce hydrocarbons. So to avoid the Grignard's reagent with moisture in the air, we use ether. Ether absorbs moisture. So the moisture is not available for the reaction. It means the Grignard reagent will react with nitrite. So in this case, what happens? Magnesium is highly electropositive, which makes this part slightly electropositive and this part slightly electronegative. Now, in CN, carbon is slightly electropositive and nitrogen is electronegative. When these two are reacted, nitrile and Grignard reagent, then the negative part of Grignard reagent gets attached to carbon, which is electropositive, and electropositive will get attached to nitrogen, which is electronegative. So that's why this C6H5 you have attached to carbon, and MgBr, which is actually electropositive, is connected to nitrogen, which is electronegative. Then in the second step, acidic hydrolysis, the NMgBr group is converted to O group. So we get ketone. The third step to produce ketones only from benzene or substituted benzene. Very important named reaction, Friedel-Crafts reaction we are talking about, Friedel-Crafts acylation here specifically. When benzene is reacted with acyl chloride, this is acyl group. Here it can be R, alkyl group, or aryl group. Both will work. So this is acyl and chlorine. So here we can say chloride. When benzene is reacted with acyl chlorides, in presence of anhydrous AlCl3, we get ketone. Now remember, the product will be aromatic because it will contain benzene ring. The other part can be aryl or alkyl, but because one benzene ring will be there, the product will be aromatic ketone. Always aromatic ketones. This is very important named reaction, as I said, Friedel-Crafts acylation. So we have talked about different methods. I'm giving you a summary, and you should be able to recall the methods. If you are not able to recall the methods, it means you need to go back to that method, come back to this screen again, and then try to recall. Only when you are able to recall all the steps, you should move forward. The first one is for both aldehydes and ketones. We talked about by oxidation of alcohols, and oxidation of alcohols was by CrO3. Primary alcohol, aldehyde, secondary alcohol, ketones. Then we talked about by dehydrogenation of alcohols. Here we talked about copper at 573 Kelvin. Again, primary alcohols will give you aldehydes, secondary alcohols will give you ketones. Tertiary alcohols will not give you any, they will give you alkenes. Then we talked about from hydrocarbons. Within hydrocarbons, we had two sub-steps by ozonolysis of alkenes and by hydration of alkynes. By ozonolysis of alkenes, we first got it reacted with ozone, formed the ozonoid, cleaved the ozonoid to form aldehydes and ketones, or a mixture of aldehyde and ketone. By hydration of alkynes, I told you that if it is ethine, in that case, if we use Hg2 plus and H2SO4, in that case, aldehyde will be produced. And in all other alkynes, if we use Hg2 plus and H2SO4, ketones will be produced. Then we talked about the methods applicable for aldehydes only. Here, only one main category was there, that is from hydrocarbons. From hydrocarbons, we talked about three subcategories. The first one by oxidation of methylbenzene. So in this case, we used chromyl chloride. In second case, we talked about using chromic oxide. In both cases, we got a chromium complex first, and a benzaldehyde was produced. When we use CrO2Cl2, that is chromyl chloride, it is important named reaction, Etard reaction. Then next one by side chain chlorination followed by hydrolysis. Here I told you it is not monochlorination. So in that case, when we use chlorine and UV light or heat, in that case, the two hydrogens of CH3 attached on the benzene ring will be replaced by chlorine. So we will get C6H5 CHCl2. Two hydrogens will be replaced by chlorine. After that, we will do hydrolysis and we will get benzaldehyde. Then the third step was by Gattermann-Koch reaction. In this reaction, we talked about that benzene can be converted to benzaldehyde. Benzene. In first two methods, we talked about toluene. In this method, we are talking about benzene, Gattermann-Koch reaction, and we used carbon monoxide with HCl and anhydrous AlCl3 or CuCl. Benzene converted to benzaldehyde. Then we talked about the methods applicable for ketones only. In this case, the first one was from acyl chlorides. In this one, we got acyl halides reacted with alkyl cadmium. That alkyl cadmium was produced during the reaction itself, and we got ketones. Second one from nitriles. In this case, we got nitriles reacted with Grignard reagent. We got the intermediate, and intermediate on hydrolysis gave us ketone. In third one from benzene or substituted benzenes, we talked about Friedel-Crafts acylation. So whether we are using benzene or we can use toluene or we can use nitrobenzene also, substituted benzenes, if we get these reacted with acyl halide, then in presence of anhydrous AlCl3, acylation takes place, Friedel-Crafts acylation, and we get ketones. Just try to recall all these ones. Congratulations, you are master of methods of preparation of aldehydes and ketones.